Robert Andrade cardiac cycle video, take 6. All right, here is my odd shaped drawing of the heart. Over here in the right atrium, kind of by the entrance from the superior vena cava, is the sinoatrial node, or the SA. Also in that same atrium, we have the atrioventricular node, or AV. And back behind the AV node, the fibers that leave are referred to as the bundle of His, and that's going to branch off to the left and to the right into fibers that kind of follow along the back side of the wall of the heart, and those are going to branch off into Purkinje fibers. Now, each heartbeat is going to begin in the right atrium at the sinoatrial node. They call this the pacemaker of the heart, the natural pacemaker. And the action potential comes from here. It's going to spread across both atria. The muscle cells are going to depolarize and contract, inducing atrial systole. The signal is going to leave the atrium for the ventricles down the septum on the bundle of His. And that bundle of His, of course, branches out. It's going to turn into the branches and then eventually the Purkinje fibers. The signal is going to spread through those ventricles, and it's going to cause those to contract, depolarize, and contract rapidly. And that is ventricular systole. Atrial repolarization occurs at that point also. Signal is then going to leave the ventricles. These walls are going to relax and recover, and that is the ventricular diastole. Also, ventricular repolarization is going to occur there also. Now down here is my little EKG. Of course, this P wave, that is going to start in the sinoatrial node, and that's where depolarization starts there. And it's going to move over here to the QRS phase, and ventricular depolarization occurs here, and so does atrial repolarization. Atrial repolarization is not really seen on the EKG because it's hidden by the activities of the ventricular depolarization. Now over here is the T wave, and that is when ventricular repolarization occurs.